Hi, so welcome to another video. So this video here is going to look at the axes on which the metal and the ligands exist, and we're going to answer the question, explain why the dxy, the dxz and the dyz orbitals lie lower in energy than the dz squared, the dx squared minus y squared orbitals in the presence of an octahedral arrangement of ligands around a central metal ion. So what it's saying here is it's saying that the dxy, the dxz and the dyz all have the lower energy level. Okay, so that's the three at the bottom. And then we have our higher ones, which are the dz squared and the dx squared minus y squared. So they're the two higher energy. Now, if we look at the image of this octahedral ligand, octahedral complex, you can see that the ligands align on the axes. Okay, so the ligands align on the x, y, z axes. Okay. So let's have a look at this. So we've got our metal in the center and we've got our 6 ligands on the XYZ axes. Now, in terms of the actual orbitals that align with these ligands, it's the dz squared, the dx squared minus y squared. So they lie on these XYZ axes. Now, what we find is the ligand repulsion for that interaction of the negative metal actually causes a higher energy to hold it in that position. When you look at the orbitals that lie between the axes of the ligands, they're the dxy, the dxz, and the dyz. Now, because they lie between the ligands, there's less repulsion felt by the central metal, and therefore they require a lower energy to have. So, the tetrahedral complexes would be the opposite because they're on the opposite axes. So you can see here, this is an image of a tetrahedral complex and it's got the different axes there. Okay, so when there's a difference in the energy levels, it's got to do with the repulsion of the ligands being in those locations. Thank you very much for watching this video, and I'll see you next time.